Hello and welcome back to Ganesh Institute channel. So today we are going to discuss how we can solve a matrix using multiplication, or you can say how do we do multiplication of two matrices. What are the factors we have to take care of in order to solve them through multiplication. So let's see with an example. Here you can see that you need to prove that AB is equal to 6I3. I is identity matrix and your A and B matrices are this. So may I ask you what's the order of these matrices? Order means row multiply column. So what is row? So row, if you see, there are three rows horizontal and three columns vertical. So order of this matrix is 3 by 3, whereas order of this matrix also, it is also 3 by 3, right? Now, whenever you have to multiply any two matrices, let's say A and B, let's say order of A matrix is m cross m. M is number of rows, n is number of column, and order of B matrix is n cross p. This is row and this is column. Then only multiplication is possible because this column of first matrix must be equal to number of rows of second matrix. So you will nullify these two and the resultant will have order as this. So m would be the number of rows and p number of columns. Okay, so let's try this now because it is easier to solve here because we can easily see it is of the same order. So of course multiplication is possible. Let's see what we will get. So this is A and this is B. Okay, now what you need to do, first of all, if you see this is your first row and this is your first column, you need to multiply. If I ask you what is the, in a matrix, there are some elements and the names are according to their position. I'll write A11 as the first element lies in first row, first column. Then in first row, second column, it will be A12 and the position would be A13, first row, third column. Then second row, first column would be this element. Second row, second column, second row, third column. Then third row, first column, third row, second column, third row, third column, right? So according to this, we have to multiply. So first of all, for this element, you need first row, first column. So you are having first row, first column, multiply these. So 1 times 2 plus 2 times 1 plus 1 times 2. Then another element will be first row, second column. So first row is here and second column is what? This one. So it would be 1 times 1 plus 2 times minus 1 plus 1 times 1, right? Then next is first row, third column. So 1 times 1 is 1, then 2 times 0 is 0, and 1 times minus 1 is minus 1. Now for this element, second row, first column, you will be having 1 times 2 is 2, 4 times 1 is minus 4, 1 times 2 is 2. Then second row, second column, so second row is this and second column is this. So 1 times 1 is 1, minus 4 times minus 1 is plus 4, 1 times 1 is plus 1. Then you have got second row, third column, so again second row and this column. So 1 times 1 is 1, minus 4 times 0 is 0, and 1 times minus 1 is minus 1. Then third row, first column, so third row, this one, and first column. 3 times 2 is 6, 0 times 1 is 0, minus 3 times 2 is 6, minus 6. So then this is your third row, second column. So this one and this one. So 3 times third row, second column, right? 3 times 1 is 3. 0 times minus 1 is 0. Minus 3 times 1 is minus 3. Then third row, third column. So this one and this one. So 3 times 1 is 3. 0 times 0 is 0. And minus 3 times minus 1 is plus 3. Right? So what have you got? 2 times 1 is 2, 2 and 2, 6. Then 1 times 1 is 1. 1 and 1, 2. 2 minus 2, 0. 1 minus 1, 0. 2 and 2, 4. Minus 4, 0. 4, 5, 6. 1 minus 1 is 0. 6 minus 6 is 0. 3 minus 3 is 0. 3 plus 3 is 6. So if you take 6 as common, you have all the diagonals as 1 and rest all other element as 0. So which is an identity matrix. So 6I3 and proved. Okay. So you just need to take care what you are doing in terms of um, what order you are having, right? Now, if I talk about, let's say if you have got any other matrix where order would not be the same. So how would you do that? So for that, remember, let's say this is 1, 2, 3, 4. So it is 2 by 2 matrix, right? Now you have got 1, 2, that is it. So now you have 2 rows and 1 column, right? So what would be the order of the resultant? This will be nullified and the resultant will be having 2 rows and 1 column, right? So for 2 rows and 1 column, what you have got? 2 rows and 1 column. So 1, 1, 1, 2. This is your order, right? So that means you have to multiply first row with first column first. So first row, this one, and first column. So 1 times 1 is 1, 2 times 2 is 4. Then you have got first row, second column. Um, Sorry, this should be second row, first column, right? Because this is first row, this is second row, and the column is 1. Correct? So second row, first column. Now you have got this one as second row and this as first column, right? So 3 times 1 is 3 plus 4 times 2 is 8. So you have got 5 and 11 as the elements of your resultant matrix. Hope you have got it. If not, then don't worry. You can comment and I'll explain further again. And if you have understood, then please don't forget to share, like, and subscribe my channel. Till my next video, take care of yourself. Bye bye.